In this class, we're going to be using the Cloud9 Integrated Development Environment, or IDE, and it's pretty user-friendly. We're not going to use all its features, but most of them are kind of self-explanatory. So you have a file browser over here on the left, and if you want to say create a new file, you can right-click and go to New File, and you can name that file something. And then if you wanted to open the file and edit, you just double-click. So, anybody that's used to using a Windows type environment can probably navigate this development environment quite easily. But the Cloud9 IDE is a full Linux or Unix terminal. Well, it's a full Linux system, so you have access to a terminal window, and that's where we're going to spend most of our time, mainly for editing programs and running programs. And so I think it's worthwhile to go into a few basic Unix commands so that you can navigate the file system a little bit from the terminal, because I think over time you'll find that it's more efficient to do this. So prepared a few slides here that are going to go over some of the kind of basic file systems commands from the Unix. So in Unix, which Linux is a variant of Unix, then everything is a file. So we have ordinary files. These could be text or binary files that run programs. We have directory files, and you have device files. So device file would be something like a printer or something like that, possibly a hard disk. So everything in Unix is a file, and the file system is sort of this inverted tree where at the uppermost level then is the root directory. So if you're used to Windows, this would be like C, something like that. That's the root directory. In Unix, it's just represented by a slash, and then underneath that you have all these directories or folders, if you will. So bin is a binary folder. This is where applications are usually stored. Dev is devices, so this is where you have a hard disk and possibly a printer. Home is where your users, so in this case there's two users, Romeo and Juliet, and then you see each of them have some files. So Romeo has a folder called programs and some kind of SQL database. Juliet has some .profile file in there. Then you have some system files where libraries and temporary files are created, and SBin is certain system executables. And then user is where most of your programs are stored. So again, in bin and SBin and lib, these are binary executables, applications, programs, libraries that you would use. And then there's one always, every Unix machine has one that's called user local. So like root user local. And this folder is kind of special because it's not touched in system upgrades. So if you were to install your own software that you'd want to live, as you possibly upgraded the system from one version to the next, nothing inside user local would be touched. So it's kind of a special folder. This is not really necessary within the Cloud9 IDE, but we can see that all of these things are there. So if we go to list, ls is a command for listing the directory. So if I list the root directory, there's all the files, and you see lib and etc and bin. Surprisingly, there's not a local, but that's okay. We're not really going to be installing anything on this guy. So what we really want to do here is learn how to create new files and folders. That's sort of the most important thing to do for the way we're going to use it in this class. So a couple of details. There's some, you can, when you navigate around in a Linux or Unix machine, you can type out the full path name, right? So that would be, if I wanted to say I started in the root directory and then I wanted to go back to my workspace, I could type out a full path name. So I could say CD for change directory, and then go to home, Ubuntu, workspace, right? So I could push the whole, right? You can also use relative path name. So let's say I wanted to change directories into Ubuntu. Well, I can use a dot for that. So I can cd dot, that means one up the tree, right? And so there you see if I do pwd, print working directory, I'm in the folder Ubuntu, which has a subfolder or directory called workspace underneath it. So again, I can then go to workspace. There's also a special character, the tilde, that takes you to your home workspace. So let's say that I'm in root and I want to go back home, my home workspace, then I would put cd tilde, and that takes me back to the home, which is workspace is a folder within right there. So again, cd is how you change directories, and you can type the absolute path, which would come all the way from root, or you can type a relative path. And there are special shortcuts. A single dot represents the current directory, and two dots represents the parent directory. So that's one directory above the one you're in. Again, a couple of commands we've talked about here. ls lists, I mean, that shows you the files that are in your directory. In this case, just the two, readme and myfile.txt. Print working directory shows you the directory you're in, pwd. And again, you can navigate around using these shortcuts. So if I want to go to the parent directory of workspace, which is Ubuntu, then I would just cd dot, and again, print working directory. You can see that that's where I am. So I'm going to clear the terminal. So here's a couple examples, but I think I just went through it in the terminal. So probably the most important thing we'll do is make and remove directories and make and move files, okay? So again, I have a couple of examples here. If you want to make a directory, you use the command make directory, and then you can also make multiple directories. You can make multiple directories inside one another. You can remove directories. Of course, this remove directory command only works if the directory is empty, which is almost never the case. You create a directory or a folder to put things in it, and so if you tried to use this remove directory command after there were certain files in my directory, then this wouldn't work. And in that case, you have to use the remove command, which we'll talk more about in a second. But basically, it's rm-r, that stands for recursively, meaning remove everything that's inside my directory and any folders that is inside of it. And this you should be very careful with, because you cannot recover from remove, and I mean that. You cannot recover from remove. It's impossible. So a couple examples then here. So if I want to create a directory, well, let's move back into workspace where the two files are, and then I'm going to create a directory I'll call my directory 1, right? So there it is, and if you can list what's in my directory 1, and you see there's nothing in there. I can actually create a directory inside my directory 1, so I can say make directory my directory 1. I'll say my subdirectory 1, right? And so now if we list what's in my directory, you should see my subdirectory 1. And of course, then we can put files in there. So I'll just touch is just a way to create kind of a blank file. So I'll put it in, call it my blank file. And now if we ls, then you see my blank file is inside there. Okay. You can also, in this case, to create the subdirectory, my subdirectory 1, my directory 1 had to exist. So if I want to create a file structure such that there's a folder inside a folder, the first folder must exist using the make directory command plain. So in other words, if I try to create my directory 2, which doesn't exist, and then inside that my subdirectory 2, I'm going to get an error because my directory 2 doesn't exist. I can't create the folder inside of it unless I put the option -p here. So if I put the option -p there, then you see that. And of course, we can also, in the Cloud9 IDE, we can navigate it this way, right? So here you see my directory 2, and inside of it is my subdirectory 2. Okay. So if there, so let's navigate into my directory 2, and then we have a subdirectory there, which we know has no files inside of it. So in this case, I can use the command my directory to remove my subdirectory 2, and now it's gone. Right? However, let's say I go up and I try to use that command on my directory 1. Now my directory 1, remember, let's go look in here. My directory 1 has a subdirectory, my subdirectory 1, and it also has my blank file inside of it, right? So if I use this remove directory command on that, it's not going to work, right? So it's saying it's not empty. So in this case, I have to use the remove -R for recursively, and there that removes it. Right? So that's making and creating directories. So we can copy and move files around. So cp is the copy command. So cp is the copy command, and here's a couple of examples. Again, if you want to copy directories, you have to use the -R option. That copies recursively, meaning all things inside of it. mv is the move command, so that just moves a file from one place to another. So when we use it in this context, if we just move file 1 to file, to file 2, essentially all we've done is renamed it. Right? So we essentially just renamed file 1 to file 2 in this context. However, what we can do sometimes is a common procedure is there's multiple files, and we want to move them all inside of a subdirectory, for example. So in this case, this command takes file 1 and file 2 and moves them into the subdirectory, my directory. So a couple of examples here. So we can take my file.txt and let's call it something different. So we can move, right, my file.txt. We can move it to a different location, which just means rename it, right? So we'll call it renamed file.txt, right? And so now you see we have renamed file.txt. We can also then copy it. So if we copy renamed file.txt to something else.txt, now we see that they're both there. And if we want to then move them, say, inside my directory 2, we can say move, and we can list out the file names like that and move them into my directory 2. Or another thing that's a little bit of a shortcut is we can use something called a wildcard. I have a slide on this in a second, but we can use a wildcard. So basically, I can put a star there, and I can say star.txt. That means everything that matches the pattern with .txt on the end of it, in this case, obviously both files, I want to move all of those into my directory 2. And so now you see they're gone. This hasn't refreshed over here, or no, in fact it did. So now you see inside my directory 2 are the 2 files that we created. Okay. Again, we can use the move command on directories as well, so we can move my directory 2 to my directory 1. It doesn't change anything that's on the inside, so my directory 1 will still have the files inside of it. So that's copying and moving files. Deleting files, we already talked a little bit about the remove command with respect to directories, but we can also use it on files themselves. So if we navigate into my directory 1, we have the 2 files in there. We can delete them, or one of them at least, like that. Now it's gone. Okay, we can go ahead and, to give another example, we can copy something else to rename file, sort of replacing it. So now it's there again, and we can use that wildcard here too. So we're going to remove all files that have a .txt on it. And so this can be a very efficient way. And this is why it's good to know some Unix commands, because imagine you had 1,000 files in your directory that you wanted, and all of them ended in .txt, and you wanted to get rid of all of them. It would be very inefficient to say, go over here and right click and say delete on all of those, right? That would not be a very efficient way to do it. There is one thing, right? This can be very dangerous. So, if you were to, for example, to run this command with the right permissions, right? So this is remove recursively, forcefully, root directory and everything after it. This would actually erase your entire hard drive. Of course, the caveat is with the right permissions. You don't have the right permissions to do this on most machines. But if you were some kind of super user that had all the correct permissions, this would erase your hard drive irrecoverably. So it's very dangerous. And one thing you can do is to protect yourself when you're first starting out with remove is to put the -I on there. And what that does is it forces it to be interactive. And so one last example here. If we were to say go up a directory, and then if I say remove -RI, so recursively because I'm going to remove a directory, and then the I means interactively, and I'll type my directory 1, it's actually going to question me, right? So it's going to say, do you really want to remove the directory? And I can say yes, and then there it's gone. And we're right back where we started.